Andrew, welcome to the podcast. I am like so psyched to talk to you, today because I have actually a ton of questions, but I'm going to compact them just into a few about you, your career journey, and also about IBM's networking journey, as well. So let's first start, with you. You know, so where have you been? What have you done in your career that all of a sudden now brings you to kind of run the networking business over at IBM?
Yeah, well, great to see you, Nick, and I'm looking forward to catching up in a couple of weeks. Oh no, great.
Yeah, so excited. Yeah, numbers are like great. It's going to be fun. 70 sessions, yeah, the whole thing. But anyway, so yeah, thank you for that. All right.
No, so just to kind of give you a thumbnail. I started my career, believe it or not, in local government in the UK, very long time ago. Just when networks were, were kind of all mainframe connectivity stuff, right? And PCs were just coming out, and we're into DECnet, and remember the wars we had over the different protocols that went over the network. Novell, IPX, IP was just one of many. So yeah, that's how I started my career, and I didn't actually start in networking, although I quickly migrated to it because I found it really interesting. So I started out programming COBOL on IC on mainframes in the UK. What a change and what a different world we live in today. Right?
Yeah, well, the financial system is still based on COBOL, so good skill to learn.
Well, so ironic, now being at IBM, to your point, right? We've got lots of customers who rely on COBOL and mainframes still today. In fact, I think most people in the world, every time you pull out a credit card and use it, you're using IBM mainframes somewhere along the way to make that happen. So.
It's really crazy, because and we probably entered the industry roughly around the same time, Andrew, but, it's like with all of the kind of mainframe bashing over the decades, it's one of the most profitable, if not the most profitable business, at IBM. It runs the world economy, as well. It's really talk about an architecture for the ages, that proves its value and continues to deliver, business value, and economic, growth value. It's like it's underappreciated.
It is, and as IBM now, I'm in IBM. We make a new mainframe model. I don't know how often, but reasonably frequent pace, right? And the latest, we put AI into mainframe chips so that we can do fraud detection transactions in real time every time you use a credit card. So there's a kind of been a massive, if you like, reinvestment of mainframes that we see every decade. So to your point, yeah, it's absolutely as relevant today as it was back then for those very specialized, high-performance transaction processing requirements, right?
Wow. I would have never thought, kind of applying AI into like the mainframe, environment, but continue on your journey. Like, I'm still want to, hear about like, how you, kind of managed your career.
Right. So I did that for a while, and I worked for central government as well. And again, back in those days, I started building some of the first IP networks in UK government when they were handing out Class B addresses like candy. So you could I applied for 4 in one go. Not that I needed all those addresses. I just thought, I'll just allocate them around the country for the various departments and things I needed. So that was kind of interesting. And this was in the days, right, with Wellfleet, early days, Synoptics, Cisco, were just, kind of switches and routers and stuff. And I kind of got into that, and I kind of loved it so much that I wanted to spend more time doing it. So I ended up on the vendor side of things, and that was kind of my migration from building and operating these networks to starting to actually be in the pre-sales support side, and then finally product management. But my big switch is I got a chance to work in Hong Kong. So I worked in Hong Kong for 12 years, actually between Hong Kong and Tokyo. I worked for startups, Xilogics and Bay Networks, then Unisphere and then Juniper, all in Asia. So, and that was a time when broadband was just taking off. We were making the transition from dial-up. So that world, and Asia went first. So South Korea, Japan, Taiwan, Hong Kong, they had and arguably still have the best broadband networks in the world.
I think I remember that. It's like we were always, in those days when we were trying to, wean people off of dial-up, we were always comparing the U.S. to South Korea.
Yeah.
as I remember, because like they were just so far ahead. Um, where we are obviously a much bigger country, U.S., but still though, it was like on a per capita basis. It's like, yeah,
Right.
they were so far ahead.
Well, it's also the investment cycles. They put fiber in at that time to make those services work, right? And we were still kind of sweating the assets, if you like. Yeah.
Hmm.
So then, after doing that for a long time, I got the opportunity to move to the US. I'd never lived in the US until I moved here, 16, 17 years ago. And so Juniper moved me here, and I continued to work for Juniper as a CTO, field CTO, essentially. And then I ran segment marketing for them. And then I did a few startups.
Yeah.
Okay, so I kind of moved backwards and forwards, big companies, small companies, until I got the call to say, "Would you like to come to work for IBM?" And I have to confess, I was kind of pretty skeptical. IBM had always, to my other point, been there, right? In the
Yeah.
background. So, what would a large company like IBM possibly want with networking today, and what would that really mean? So the opportunity was really
Yeah.
to refocus IBM on networking in a way that we hadn't had for probably 15, 20 years.
Yeah.
And it was really born of a problem that IBM had helped create, which was that as IBM had helped customers migrate to what we call the hybrid cloud, so a mixture of workloads running on-prem in the cloud, they kind of created a whole lot of networking problems for their customers.
Yeah. Hmm.
And those problems are really around complexity.
Yeah.
And if you think about what IBM really does, and for all of its history, really, it's really been about process and how you automate processes, right? From the first tabulation machines to the first computers, to the first mainframes, to the PC, really about making our lives simpler, automating those things. And so whenever we see a problem that's getting way more complicated, we kind of look for the opportunity to simplify it and automate it.
Yeah. Well.
So that was 3 years ago. We've now done 5 acquisitions in networking. The latest just a couple of weeks ago. Well, actually 6 if the proposed acquisition that we've just announced kind of goes through. Right, but there's a lot of things that are kind of in flight around what we're building, particularly around this. That's simplifying, automating what it takes to actually run networks together with compute in this hybrid cloud world, and that's really been the journey we've been on.
Yeah. Well, that's an amazing journey, so far, so, going from kind of building, networks, into like onto the vendor side of things, being there, right in the middle of it. And I was there, as well, like in the early 1990s and the mid 1990s, when kind of networking just really took off, the first bridges and routers. I worked at DEC at the time. So I was at Digital while you were, at some of these other companies. And, so we were doing kind of all the LAN bridges. We were using microvaxes, for routers, at the time too. And then, but anyway, so like that was a real fascinating period, I think in the industry, because we were all, everyone was placing bets and trying to figure out, how do we really scale this whole thing up, and how do we establish norms, and protocols that will allow this to scale up, and then how do we now kind of unleash this, thing called the internet, into the economy, and see how it and see how we can, I don't think we really anticipated it being kind of the backbone of the global economy, that it is, today. But I think anyone who was like working in the industry at that time, that's we were privileged, to be there, and to contribute and to participate in the building of the internet. I think that was a great calling for like our generation, and I think we have. You don't get this really very often, but now we have, kind of a second time doing that now around with AI. But anyway, so I love that. I love your journey, and I love your, career path. So behind you, are you in California?
I am, and I'm on
Okay.
the IBM campus, which is just south of San Jose, which doesn't look very Silicon Valley like, does it? It kind of looks bucolic, but we're
Um,
fifteen
I
minutes.
was like, for some reason I'm thinking North Carolina, or I'm thinking out, in the valley, so it does have a valley look to it. You got the mountains in the background there,
Got the hills. Yeah,
Awesome.
so this campus actually just on the vignette was built in 1974, I think, 1974, 1975, as the first software development center that IBM ever built, and maybe one of the few that were ever built, specifically designed not for hardware but for software development.
Wow. Yeah. Yeah. And in 74, yeah. So, okay. Well, and I love the way that you kind of like, really went into like IBM's focused around networking, because I do remember the times of IBM and networking. I do remember the SNA
Yep.
and TCP/IP, transition that happened. That was a huge, massive transition, and that clearly impacted the 3270s, and the cluster controller, marketplace. And so that was I think that was probably the final transition, of TCP/IP kind of being the de facto standard, for how we connect computer systems, across the globe.
Right.
So,
Well, like,
and IBM was big, that SNA market was massive. It was like super big.
and token ring. I like to joke that I got my networking career because of token ring, because I don't know if you remember this, but token ring used to click when it connected to the network. There's a little relay inside the line cards, and so if
No,
it
I don't
didn't
remember that.
click, then and the computer was off, then it would bring the network down.
Huh.
So the joke is I got into networking because my hearing was really good, and I could hear when these things clicked, and I walk in the room and go, "Yep, that one." That's why
You
the
better get
network's
that
down.
friggin' click, if it's going to bring the network down. No, I didn't know that. It's like the only thing I remember clicking is an RJ11 or
Oh,
RJ45 when you
absolutely.
plug in. It's like, that's it. Yeah. I was from DEC, so I was like more Ethernet,
Right.
kind of like, Ethernet grounded. So, okay, so great. So now it's like, okay, great. Uh, no doubt, networks have gotten, they always get complex like every year, but seems to be a real focus around simplification and trying to get control over this, because as you get, complexity inflation, you also get obviously costs get out of hand because you're throwing people and you're throwing tools at it. So, all right, so let's talk about now. All right, so IBM, reestablished into the networking space, and so the area that you're focused on, kind of like product services, not like an encyclopedia, but like just
Yeah.
just to zero in, and also where does the networking group fit in organizationally,
Right.
within IBM?
Well, right. We talked about complexity in the days when there was .NET and IPX and IP, and there's probably dozens we've forgotten that were kind of floating around, and that created its complexity. So the complexity
Yeah.
today is we're in the world of AWS and Azure and Google and on-prem, and
Mm.
can kind of think about the vendor landscape. I like to call it the Noah's Ark. Of every company has at least two of everything. They've got two types of
Oh,
firewalls, two types of SD-WAN boxes, so the proliferation of all these different things has made the journey really, really hard, right?
yeah.
So as we built the team, the networking team here at IBM, we really wanted to make sure we were feeding the rest of the IBM organization with network capabilities. Because obviously, for the rank and file IBM sales team and the partners we have, they're not going to go in and be able to, not every one of them, have a deep conversation about networking. But what they
Yeah.
can have a deep conversation around is the performance of applications. And that's really the impact that is kind of the unknowns, if you like, about running applications today. There's so many
Mm.
variables that play into it. We like to say that slow is the new down. It's kind of
Slow
interesting.
is new down.
Right?
Explain. What do you mean?
So if you think about it, if you go to a website and you're, I don't know, whether you're shopping, whether you want to book a restaurant, with you, and it's delayed for more than a
Oh,
third of a second with every response,
oh,
the abandonment rate, and we've done research on this, the abandonment rate is something like 56%.
wow.
Conversely, and this is
Mm.
incredible, if on a website you can increase your response rate by zero point 0.1 of a second, then your sales go up by 10%.
Wow. Huh.
So there's an absolute obsession with our customers around the performance of their applications.
Okay. Well, that is so kind of crystal clear. That was a great analogy, kind of great causality, around delay, and and for those who are revenue generator or revenue facing kind of applications. Yeah.
Okay. It kind
Okay.
of makes
So I'm
sense, right?
sorry. Continue. I
Yeah.
hope I didn't cut you off.
No, not at all. And it's kind of like So the impact of that, and the problem with that is that today, most heads of networks and the application teams and developers, they don't control all the elements that sit around that. So in the mainframe world, of which I grew up, right, mini computers, we controlled everything from every device
Sure.
owned and managed, dark fiber, at least it was, and so and there were fewer components, right? So we could manage everything in that pipeline so that the terminal was no different, like the terminals would support. So today, when you don't own the infrastructure, it's much harder to try and make that thing deterministic.
That's true.
So to I guess almost solve the impossible, how do you make an indeterminate, non-deterministic environment as deterministic as possible so that you can raise the performance levels and create resiliency for the applications? And that's really what we've been about with the journey we've been on with the acquisitions that we've done. So, for example, we realized we needed a lot more information. We need the observability side of the networks, both on the physical infrastructure and the virtual infrastructure. So we acquired a company called SevOne. SevOne is used by 8 out of the top 10 global banks to manage the network components, everything from Wi-Fi through to the AWS instances, look at all the network components, and then turn that into an application view. So what's the latency for this application end to end? That horrible question is like, where is it in the network that's present? Is it the Wi-Fi is getting poor reception? Is it the SD-WAN that's congested? And so to be able to answer those questions and really track the performance of applications as it relates to networks. So that was an important kind of first step. We acquired a company called NS1, which is a authority DNS company last year, and people were quite confused about why IBM was interested in DNS. It seems kind of a strange direction to take. Well, it turns out that a lot of what we do with that product is about managing the performance and latency of how you receive your experience across the internet. And so whenever you type the URL, right, we're making decisions on your behalf about which CDN is better to use right now. You're in Chicago, but is it better to move your traffic to Detroit right now because we've got congestion in the area? So we see about a third of the internet traffic through NS1. And we plant a little piece of Java script together with our customers that gives us the performance stat for each one of those connections. And so, again, a very indeterminate environment we're making as deterministic as possible because we're making choices on a second-by-second basis as to where to move, where to suggest your computer goes to go pick up that service. So again, we're having the observability side, but observability is nothing without actionability. So with NS1, we can take that action and make decisions on where traffic goes.
Okay.
So
far, so good. Yeah. So SevOne, NS1, actually two good. I know both of those companies. I knew them before they were acquired. Two great companies. As well. So yeah. So okay, building the observability, kind of tool set.
Right. And so then the kind of follow on, and something we ended up building mostly organically. We did acquire a company called Volta Networks, which gave us some IP expertise and a kind of routing stack and things. Was what I call the multi-cloud networking problem. So how do you connect the clouds together easily, simply, again, application level? So how can application developers say, I'm going to drag this database so it connects this web front end? And one might be in AWS, one might be on-prem, or in IBM Cloud, and because we can think about applications as having a lot of different kind of tendrils that go off in all kinds of directions to go pick up information and process whatever it is that you're doing. A user login system, so a single sign-on ID, through to a stock database, through to even what the weather is doing right now. And any one of those things, which is slow in responding or offline, can break the chain and delay the performance of the application. So we wanted to make those connections explicit and application level. So today, when you connect clouds together, quite often you just connect subnet to subnet. Sometimes you have to map this over. But if we could just abstract it to application and have the network complexity hidden from the application developers, while still giving the security team and the network teams control of where traffic flowed.
Yeah.
So, as an example, right, for banking is a great example. You connect London to Tokyo, or London to New York. How do you know which other countries the traffic goes through before it gets to the destination? Are you even allowed to send traffic from a compliance and regulation perspective to those places? Can you put your hand on your heart and say it doesn't go there when I move traffic between two zones within a cloud or between cloud and on-prem? So these are the kinds of things that we can start to make more deterministic by breaking out that traffic and partnering with the telco, for example, to say we'll move this onto telco environment to guarantee the performance across a segment because it's that important. So that's a hybrid cloud mesh product which we released in December. I've got some really big announcements.
That's really good. I love that. I love the background that you provided, on that, because, you're even starting to see some of the cloud providers like Oracle and Microsoft provide like inter-architecture, connections, so that if your database is like kind of running in Oracle and, your application storage is located, in Azure, and kind of the app front end maybe is running like in on-prem to facilitate that. But it's so nascent, in that, kind of multi-cloud kind of application pipeline, on where all the data resides. So that's actually really great. And also, since you're kind of looking at the application, its pipeline for data flow, and also its dependency map, and trying to control that, and to provide some deterministic, elements associated with it. That's, to reduce the delay, or to assure certain kind of like criteria, around the delay of a website performing. This is all starting to really make so much sense. Andrew, that's super, because like, the last survey that we've done across the ONO community is that almost 50%, 50, on average, is not owned by kind of a consumer, a corporation, but it's a service, and that's a stark difference, from like, just like 5 to 10 years ago, where they own most of that infrastructure. But continue. So this you're painting a really great picture, So thank you.
But to your point, right, it was interesting as we were designing the products and what we were going to build and what we were going to buy. We obviously interviewed lots of heads of networks at lots of major corporations, and almost every conversation we had turned into a therapy session. Because to your point, right, half of their infrastructure is gone. It's like, so you sit down and you start the conversation. So, you wouldn't believe what happened last week, right? This workload was moved to the cloud and nobody told me, and now the latency's gone to hell, and it's my fault, even though I don't control the infrastructure. You can imagine, right? And so that kind of led us to just exactly down this path. So the other element that we're focused on is automation. We've made one acquisition called Pliant, which is around that, and we've just announced an intent to acquire HashiCorp, which you may have seen.
That's right. Yeah. No, I did see. Yeah. So is that coming out of the networking group?
It's mixed, because HashiCorp obviously has implications for infrastructure management, which is how they got going. Networking is a big component of that, but not all of it, and of course security with the Vault product. Yeah. So we're obviously really excited about that. We again, it comes down to how do we normalize the experience of being able to deploy and manage applications in the cloud. And to your point about getting two clouds together and so on. The problem with that is that you end up having expertise in Azure and expertise in AWS and expertise in Oracle or IBM Cloud.
For sure,
There's a whole career track you can play with each of those. And so getting those folks in a room just to connect an application together is crazy. That's what's required with that level of complexity and detail. And so if we can normalize that experience, so the deployment, particularly in the Kubernetes environment, given our Red Hat heritage, it plays so well to that, right? In a way that is made common between the clouds, and with the same level of observability, with the same firewall rule set, with the same application connectivity. You can see how these things start to link together. And Pliant's, a much smaller acquisition, obviously, than HashiCorp, but a fairly young company, but very key technology, because we're trying to move away from having to script everything to make these things happen. As much as we love Ansible, and obviously a lot of things, if Ansible is used incorrectly, it's like it can be like pouring concrete. You're setting yourself up for problems later. It's like it's beautifully flexible, and you can make it into any design you want, but then it's hard code, and somebody has to manage that code for the rest of their careers. To the same point about probably could still go back into our mainframe worlds and go do that if we wanted to still a career there, right? That's the case with these scripts. They just live forever. And yet they have to be maintained because you update a version of a firewall or a router, and now your script's broken. So how do you abstract that, and how do you make it simple to kind of drag and drop network components together and say, here's a simple API. I say, here's the firewall rule I want to push. Don't care whether it's Fortinet box, Palo Alto box, or something else. It's just going to translate it and make that work for me. That really is the way we've planned it.
Yeah, this is like really, Andrew, thank you so much for kind of going through this. And because it makes the grand plan makes so much sense, so it's really kind of rooted in how applications are being built, especially across multiple different cloud providers. So you have both the observability pieces, so you can kind of understand the underlying application dependency map and what might be impacting delay and user experience. Now you also have kind of the templating, and how to kind of facilitate the building up or building out of applications that are across multiple different, cloud providers. And then you also have now kind of a better way in order to do orchestration, as well. So that's not kind of bound to particular scripts. And you're right, scripts are almost like firewall, rules and ACLs. They grow and they break, and then someone's got to figure out how it was configured and how it was, what its purpose is, and you have to just spend a lot of time diving into that stuff. You need some kind of network ninjas to kind of dive into it. But anyway, so I think that is super great. I'm so now I thank you. I now understand the overall strategy, and how IBM networking, what you've been focused on, and now the bringing together of these acquisitions, and now kind of understanding the unifying theory, around all that. Right. So, but what else is there? I don't want to I didn't. If there's more, I'm sure there is, but.
Okay. We started the conversation around AI in my friends, right? Yeah. So, obviously, IBM is pretty deeply invested in AI and has been for a long time, and we've got our own models. We've got Granite, we've got what's next to AI, and so on. So one of the things we realized in networking is that in order for AI to be successful, it has to have knowledge, it has to be able to get information, and it has to be able to take action. And we tend to think of AI a bit like a genie, right? You can ask it anything, and it tells you anything, and do anything. Yeah. So we're giving AI these attributes of omniscience, all-seeing, and omnipotence, or powerful. So in a network world, you want it to be able to see everything that's going on, have a source of truth for everything, and then make decisions. So imagine summoning a genie from a bottle that didn't know anything and couldn't do anything. Not really very, very useful.
Not very helpful, So maybe kind of nice to look at, but that's about it.
But, right. So I think it's kind of interesting then that we're seeing corporations try and wave a magic wand of AI and expect it to just, I don't know, magically, to use my analogy, kind of find stuff and do stuff. It doesn't work that way, right? So a lot of the journeys, and whether it's the kind of, I call it pure AI and business process side, whether it's networking, it's about how do you make sure you're giving and getting the right data sets, the right information, and also giving the thing teeth so it can actually take action. So as to the extent we're applying AI into networking to go find things, predict things, and then take action, it has to be able to get to this level of data, and it has to be in a way that can be consumed. So if you're not collecting data from all the different parts of your network and not making that available to AI, then you've got a hole, and it's not going to be able to it's not going to make great decisions, or worse, it's going to hallucinate about the problems you have. So on the
and
AI journey,
and all of those hallucinations are really bad trips. Because it's like when you got a bad hallucination on like a network configuration or a network design, and all of a sudden this genie starts making changes. Yeah, it's
yeah, it's not
bad
good. And
outcomes.
bad
you
outcomes,
know,
right? And,
yeah,
and it breaks the trust that we want to place in AI to be able to do
yeah,
things. The other
yeah.
thing that's really important is that LLMs that we kind of use in our daily lives now are not great at time series data, and this isn't
Mm,
well understood. So, in networking particularly, finding out what happened or what changed or what's broken is a function of looking at things over time. And so LLMs will surmise all the information in one go, but they're not great at saying, oh, this changed here. Right?
mm,
So using different AI techniques, graph, and there's quite a few of them actually, in combination with LLMs is actually going to be really important to getting time series data into this is what changed, or this is what we're predicting will happen as a consequence of this change that we'll make. Or this is what
yeah,
happens when you change your network or deploy here. And it all goes back to, and what's the implication to the application? What's the performance of the application? So,
yeah,
uh, so domain by domain, we're looking at how we're applying AI because the models that we use for, say, Wi-Fi and the learnings that will happen, they will be different to what we use to look at the IP network. It will be
mm,
different to what we look at
yeah,
inside a cloud and application deployment. So we're starting to see how individual, quite specialized models that understand time series data need to be applied to different parts of the network and then aggregated to provide the answer about, okay, so what changed or what's broken or what went wrong or why is my application performing poorly right now?
yeah. Oh, no, that makes so much sense. But continue. I do have kind of a couple of questions here. But go
Yeah,
ahead,
right. No,
Andrew.
we're on the journey. I think, like a lot of companies, we're on a journey with that, and with the companies we're working with very closely on their data and getting very specific answers to their particular problem sets and kind of moving through like that. Obviously, my job running a product organization is to productize that.
Yeah,
So my message really right now for our customers is you get ready for the data, get ready with the orchestration, so that you're able to see everything you need. You have the right level of observability, and you can take action. So give the genie, if you like, the right level of skills so that
mm,
it can take action. And then as the models come along, whether from us or from other people, they'll be applicable into your world,
yeah.
and you can take action on them.
I love this. This really kind of focuses on lifecycle management, and the automation of lifecycle management. So, being able to kind of pull data, from a dependency map, of an application, and being able to kind of feed that, data, whether those are logs, telemetry, state, information across all those different components. And then what I love about your thinking here is that it's not just like one kind of like AI model, that kind of the network AI model. But I think this, I haven't heard this anywhere other than from you right now, and that is um, the probably the best thing would be is to have AI models for particular disciplines. Whether that is like for Wi-Fi, or for routing, for switching, for IP addressing, BGP, what have you. So that specialize, just like people, in large organizations specialize in their particular disciplines, do the same thing, with AI. And then the question is, how do you federate that information and summarize it, up so that it can either identify anomalies or identify changes in configurations that might have implications to policy or compliance, or just may predict, a bad outcome. So I think that's the way I kind of summarize on where you're going with this. And I think if so, do I have that right?
Yeah,
Do I
that's
have
right,
that
and you're right.
model?
So you have to federate. So you get layers of models essentially. So a model
Yeah,
might have expertise in one of those things, one of those different disciplines, and then an Uber model then looks at that information and says, okay, it was the Wi-Fi, it was the backbone for these reasons, and that's what caused this.
yeah,
Because to the medical example, a patient's entitled to have as many diseases as they want, right? So quite often it's multiple things that can lead up to something, right? And worst of all is the things that deteriorate over time, right? You get more users on a system, you get more people in the Wi-Fi network, and you get they start to aggregate, and the performance degradation is subtle until something breaks.
Yeah.
And it's quite difficult as humans to go back and understand what that trigger point was. Right?
Yeah. That's interesting. And all of this is kind of leading back into kind of that whole point around the way that a business value is maintained is to make sure the experience of the consumer of your brand is as high as possible. So don't delay when they're interacting with your brand, whether that's buying something or whether it's just like asking for information, or whether that is searching your site or what have you. So it's
Right.
rooted in a user experience. All of this back end and the automation of the back end. And I think that is it's profoundly simple and powerful at the same time. That's a really great unified theory, and also just like value prop. That I think everyone can understand pretty quickly and easily in the industry. So I think
Yeah.
that's really good. So now, all right, I do have kind of a how-to question. So on the data, or getting that data. So like today, so these are the logs, and this is the telemetry, and this is like all of the data that come from all of the various different components of a dependency map. So they may be owned by different companies. Obviously, some of them will be a service, some of them will be maybe on-prem. There'll be holes in that data. So first, maybe there's two parts of the question. One is that holes in the data, which will invariably be, and then the second part is that there's no real standard, that we have in the industry to emit in a canonical format, in a standardized schema, so that can be deposited into, whether that's a data lake or some other mechanism to consume, and then store it, so you can actually have applications or AIs kind of work on that data. So maybe on the first part is, without having a common schema, you could go to like having different modules for different vendors, and then those go into a canonical. So let's first talk about that, and how do you kind of foresee the standardizing of the data, problem being solved?
So I don't know. It does get standardized. I think just thinking about my own world, right? With Sev One, we're taking data from everything from SNMP, IPFix, gRPC, right? And but we've got a specific outcome we want. We want that data to be as real time as possible, meaning that
Mm-hmm.
if you ask for a report, you should be able to make a few clicks, and within seconds you've got your answer. So not the sit there, we'll come back tomorrow, come back in 2 hours, and we'll process the data. And so I think different vendors are going after the problem differently, depending on the outcome that you want, right? So for the flexibility that we have, we're based on let's get this thing into time zero. Let's get this thing into kind of immediacy of response.
Yeah.
So the normalization is really right now down to different vendors and how they're pulling in that information.
Yeah.
But I haven't seen a push to just like create a standard around what that looks like, because I don't know even what that means, right? So because increasingly we're pulling from different, not just these dynamic sources of logs and things like that, but from context, right?
Yeah.
So for example, Helm charts are a really important context for things,
Hmm.
right? Because they tell you
Good point.
how an application is supposed to be deployed. We aren't pulling from that data source to equip today, but from an AI perspective, it makes sense to do that, because then you've got
Yeah.
a learning experience. So a lot of the outcomes come to be is what you anticipate, what you want it to do, what the reality is.
Hmm.
And so we're pulling from these many different places. We are defining policy for what we do in a very indirect way, meaning that how an application runs, how much memory it consumes, where it runs, what network connectivity it has, what security it has, is just very, very spread out. It's implicit policy.
Yeah.
So maybe there's an
Very true.
opportunity to create explicit policy and have that published as the standard. But I
Yeah.
don't think we're going to get that we have an opportunity of getting right, if you like, as an industry. I don't see that we're going to be able to normalize the sources of all these very discrete, separated sets of data into one output file, if you like, that is normalized. And
So I think
honestly,
that,
yeah,
no, go
I
ahead. I'll continue.
was going to say, honestly, that's where a lot of intellectual property gets created by the vendor community
Yeah.
in being able to offer value as a consequence of that. Right?
Yeah. So I'm with you. So I think that's probably, that's the realist view on how that gets solved. So there won't be, some organization that is able to kind of standardize all that data. They would be more than likely either modules that do that, you know, canonicalizing of the data, but that would be proprietary for a particular ecosystem. So I think that's probably how, that makes sense. It's unfortunate, but I think that's probably the reality, on how that will go. And I think that will kind of still create, big holes in the visibility,
It,
of the infrastructure.
it may do, but also think about how we're using LLMs almost as a data store. Right? So we're collecting all this information, and it's almost like a massive compression algorithm, right?
Yeah.
So, for example, if I go to ChatGPT or Granite and I say, who was the first person to land on the moon, right? It's not storing that information canonically or in an index file, but it knows the answer,
Yeah.
right?
Yeah.
I hope it does. And so when we think about using LLMs and AI kind of writ large to look at our data and provide answers for that, the data store that's created model by model kind of looks like a proprietary database in some way. You can never get directly to the information in a stream sense, but it does have the answers. It does know.
Hmm.
So a lot of the focus that we've had as IBM on these models is to confine them so they only know the things that you tell them it should know.
Hmm.
So
Makes
if I
sense.
ask
Yeah.
my networking model who was the first person to land on the moon, it shouldn't know the answer to that question.
Yeah. True. I shouldn't. Very, very true.
Right? So then we've
Okay.
got a system that, while it looks proprietary, it's absorbed information from dozens of different systems. Right?
Okay. So, all right. So I think I got that. And actually, and then you also answered the second one around not having full set of data. How will, these systems kind of fill that in? So I think you just answered that.
You can plug, yeah. I mean, you can plug it. So you might not get precise granularity of things. For example, if you take IPFix, so you see what communicates with what at every time, you might see an event happen, but you don't have a corresponding syslog entry for it.
Yeah.
With a human and with machine learning, you can infer what happened, or you might be able to infer what happened, or
Yeah.
it could be a gap, right? I mean, but that's the nature of it.
Yeah. I think that's the question. It's like, how much is enough, right? It's like, you don't need to have 100%, of all the data, on the current state, maybe of a large infrastructure. But maybe you can still infer by having, I don't know, 60%, 50%, of the data. But I think that's one. I think that is kind of a challenge for our industry as we move into this space. And I think that's, it's good to know, good to keep an eye on, and that could also be a means for competitive differentiation between different
Right.
companies, as well. But you mentioned one other thing too that I want to, kind of touch on because I think it's really important, and that is around policy and having, implicit versus explicit policy. And to me, I think let's assume, that we have we have a schema, we have all the data we need, we have great insight into the infrastructure, and that infrastructure is trusted. So we've built this really great trusted infrastructure, and now we can have explicit policy for particular, maybe users and applications, and then the application can signal the infrastructure to deliver that explicit policy. And then the infrastructure configures, it
Right.
delivers and it monitors and it maintains that. So now, going back to like our earlier conversation, so now what you would have is you would have a known structure that you can control.
Right.
And so it's not, undeterministic. It's deterministic now,
Yeah.
you
Well,
know?
as deterministic as you can make that environment. There's still
Yeah.
things that are outside your control. But yeah, so the key in that is APIs. Interestingly,
Mm, yeah.
so a lot of
Makes
what
sense. Yeah.
we're doing is the abstraction of infrastructure comes down to providing an API that an application can call. So when it asks for things,
Hmm.
it's asking through 3 or 4 parameters. It pushes through an API, and what happens behind the scenes might be incredibly complicated and deep. And the other thing that's linked to this is, you mentioned trust. It's a trusted environment, but trusted in what sense, right? Is an application doing what it's allowed to do? Is it constrained in a way that it should be?
Mm.
If somebody has accidentally created more or consumed more CPU than they planned to, what does that look like? How do you manage? And cost becomes an element to this. My colleagues over in our automation group acquired Aptio is a good example. And Aptio is a way of planning and managing the cost of deploying applications.
Mm.
Because I don't think any CFO of any large organization hasn't had had the horror shock looking at the cost of their cloud
Oh my God.
services.
Yeah. It's like,
It's like,
you spent what? Yeah.
how the
Yeah.
hell did that happen, right?
Yeah.
So, and that's the beauty of cloud services. They're kind of designed that way to be so easy to consume. So there's a whole
So easy.
industry that's been built on how you contain those costs.
Yeah.
And so, from IBM perspective, so that's policy too, right?
Yeah. Sure.
What am I going to allow this application to do? So that comes up, and maybe the final point of what we talked about. There is everything we've talked about touches on both infrastructure and networking as happening together and in
Yeah.
unison, right? And that's not always and often how enterprises build their teams.
True.
The
Very
network
true.
team, security team is very separate from the application team. And
Yeah.
so there's almost a cultural change that some of this implies, that if you're going to centralize, if you have one policy for what applications do, which incorporates networks, which is a good third of what that configuration management is, then you need to have those groups working very, very tightly together.
Yeah.
And so as the tools come together, we have to, for example, when we built our hybrid cloud mesh product, deliberately gave separate screens to the network teams than the
Mm.
application teams. So we
Yeah.
could speak application language to the application folks and network that speak to the network folks, knowing that they didn't speak each other's languages, right?
Yeah.
And so I don't know how we break that boundary down, but I think to realize some of the value that we talked about today, particularly around AI, we're going to have to break those boundaries down and put the application as and give that primacy, if you like, and surround the network architecture and the compute architecture together in that environment.
Yeah. We've been thinking a lot about this, and it's kind of like the redesign of kind of IT infrastructure. And like, if we look at the course of our careers, right? We go back to the very beginning, they were really just system architects, right? That would kind of like that would manage, they would interact with the business, and they would kind of, then they would electrify, electronicalize, whatever, digitize, those applications in that business. And then really PCs and the internet came along, and then we started to build these stovepipes or these silos, right? And so there's massive change in computing drove changes, and it was a mirror reflection on how IT had organized themselves in order to kind of extract the value from that and deliver, it for their corporation and their shareholders. And I think probably the same thing is happening here. Now it's like, we'll probably see like over the next couple of years a rethinking of organization design within large organizations as the kinds of AI infrastructure gets built that we've been talking about here, where those silos do get knocked down. Because like even like we didn't really mention security that much into all of this, but it's inherent in it. It's like if you have observability, you're not just looking for like network changes or network configuration changes, you can also be looking for anomalies, and to be able to then, trigger, various different systems based upon those anomalies to mitigate them. So it accelerates the whole network and security
Yeah.
teams to come together and those industries to come together. It clearly accelerates the whole software defined world that we've been talking about for a long time, in the industry, and we've been delivering on that. But I think now it's like with cloud and also with kind of the AI steroids on this. There's a real opportunity. It's not an opportunity. It's going to happen. It's going to like be a change in the way organizations are organized. To be able to manage this and extract the maximum amount of value from it, so they get the outcomes that they're all looking for.
Right, and it kind of falls out. And I know quite a few heads of networks, major corporations. They spend 60-70% of their time just on compliance.
Yeah. Yeah.
Can you prove that this application only talks to these people in this environment and the traffic doesn't go through any of these places it shouldn't? Right, and those proof points, when you have good policy and you have good tools, compliance falls out of it.
Yeah.
I met a head of a major bank a couple of weeks ago who was using spreadsheets to track all this information.
Wow. That's a little disappointing to hear, but sure, it's all over the place. Yeah, I know.
So
Well,
lots of opportunities.
yeah. Oh my God, yeah. So, actually, I do want to. I have like one or two other things, Andrew. So, James Walker is with IBM.
Yes.
Pablo Espinosa,
Yeah.
is with IBM. So, how do they fit into what you're doing? And the reason I'm mentioning them, for breaking down the fourth wall here, is that they were both new board members, and
Right.
James was at Bank of America for the longest time,
Yeah.
and Pablo was over at Target. So yeah. So what
That's
are those
right.
guys doing?
Yeah. So Pablo is running the network for our internal infrastructure within our CIO group. IBM's got quite a few employees, over 300,000 or something. So plus all of the, it's a pretty big network. I lost count. It's 120 countries we operate in. I mean, it's a lot of places.
Wow, good for Pablo.
And a lot of modernization, as you can imagine, that we're going through, and we're going through the same kind of journeys that every other large enterprise is going through. Migration to SD-WAN, relooking at where our applications are, how many applications do we have, do we really need that many, where does it, and of course application performance. So Pablo is fast becoming my biggest internal customer, as you can imagine.
Awesome.
so that's that. And then James is running the network for our cloud group. So IBM Cloud, the focus we have on, particularly on the financial segment, given his history at Bank of America, is kind of perfect for that role. So similarly, modernization of infrastructure, focused on resiliency, focused on the performance of the applications of our customers in that world. So yeah, between the three of us, we're kind of setting the agenda, if you like, for how IBM thinks about networking for our own internal consumption, for our customers' consumption, for our products.
Yeah, well, that's a great brain trust, that you have, and this has been, it's a fascinating discussion for me, Andrew. I'm like, I know so much more now about IBM Networking's focus, and their go-to-market strategies, and also like where you're, guiding and taking this, So, thank you so much for sharing that and being on the podcast, as well.
No, well, thanks. It's been a great conversation. I really enjoyed it. So thank you.
Oh, awesome, great, and thanks everyone for plugging in. Thanks, Andrew.